Hi everyone, and welcome back to the series of circuit practice problems. And today we will have a problem about superposition. In this problem, we want to find the output voltage that is across the 1 kilo ohm, and we have here three sources. So we will be removing two sources at a time. We'll keep only one source and find the voltage due to that specific source. And then we will add the three voltages which are due to the individual independent sources, and then that would be the total voltage due to the three supplies at the same time in the circuit. So let's start. So here I removed basically the two voltage sources. How we remove the voltage source? We short circuit them because we want to set the voltage equal to 0, and that will be basically a short circuit. Now let me number the nodes here of the circuit. Now, this is node number 1. This is node number 2, and this is node number 3. So clearly you see that this 1 kilo, and the 2 kilo, they are all in parallel, and there will be one resistance. So let me redraw the circuit now. We'll have here the 4 milliamp resistance, and then we will have here the 1 kilo ohm, the 2 kilo ohm resistance. So now we have here node number 1. This is node number 2. Now these three resistors, now doesn't matter what's their value. We'll see why. This is not important. Now this resistance here between node number 2 and node number 3, and this is your V output 1. So we see here that node number 3 is floating, is not connected to the 4 milliamp or in the circuit that contains the 4 milliamp. So the current will go here, current goes there, and will come back from this side. So it goes split here and there, come back here, and go and keep on circulating. No power, no energy will be supplied to this floating branch. Hence, your V01 is basically is equal to 0. So in this specific circuit, this current source actually, it does not contribute to this voltage. So you can have any value here of the current source, and you will get exactly the same answer, because that specific current source has no contribution to the output voltage. Now, let's remove now the current source and the 12-volt voltage source. And again, let me number the nodes. So this is node number 1, this is node number 2, number 3, and number 4. So what you can notice here, resistors 2 kilo and 1 kilo, they are basically in series, because they are sharing one node and nothing else is sharing that specific node. The 1 kilo and the 1 kilo, they are in parallel because they are sharing nodes 3 and 4. So the 1 kilo parallel with 1 kilo, and we know that when we have two resistors in parallel, and if they are equal, then the total resistance is half of that resistor. So that is the total resistance. You can do that also using a formula. It's 1K times 1K divided by 1K plus 1K. So let me redraw the circuit now after adding these two resistors in series and these two in parallel. So we will have basically here 3 kilo ohm resistance, which will be between nodes number 2 and node number 3. We will have here the voltage supply plus minus. Okay, this is the 6 volt, and we will have here the 1 kilo in parallel with the 1 kilo, which is the 0.5 kilo ohm, and your output voltage V02 is across this resistance, and we will have here the 2 kilo ohm resistance. Okay, so you can apply different things here. You can apply mesh analysis. You can apply KVL here. It's very straightforward KVL. The current I here split to I1 and I2. So if you apply KVL to this loop, Okay, so this is loop number 1. Okay, loop KVL to loop number 1. You have only one unknown, which is I1. So basically you will have, if you take the apply KVL, so this is plus minus, this is plus minus. Okay, so we'll have 2K I1 plus 0.5 K I1 minus 6 equal to 0. So your I1 is equal to 6 divided by 2.5 K. Now your V02, now V02, its polarity is the opposite of the polarity created by I1. So it will be minus 6 over 2.5 kilo times 0.5 kilo. And this will give me minus 1.2 volt. So that is V02. Now let's go and find the V03 when we have only the 12 volt supply. So now we can see here that this and this, they are in parallel. Again, 1 and 2 in series. So this is node number 1, 2, 3, and 4. So these two are in parallel. So it is 1 times 2 over 1 plus 2, which is 2 over 3 kilo ohm resistance. Okay, now let me basically redraw the circuit. So we will have here 3 kilo ohm, 2 kilo ohm, and then here we have not 2 kilos, this is 2 over 3 kilo. This is the resultant resistance. And this is minus plus 12 volt. And I'm interested to calculate the voltage across the 1 kilo ohm resistance. Okay, and here is the polarity plus minus of V03. So again, a current here I, you will have here I1 and I2. I'm only interested in I1. So apply KVL again to this loop. So we will have 1K I1 plus minus plus 2 over 3K I1 minus 12. This is equal to 0. So we will have basically 5 over 3K I1 is equal to 12. So your I1 is equal to 12 times 3 over 5. Okay. And this is equal to 36 over 5K amps. This is your I1. Okay. Then your V out 3 will equal to the 1K times 36 over 5K. The K will cancel and we'll get 7.2 volt. So your V output is equal to V01 plus V02 plus V03, which is 0, minus 1.2 plus 7.2. And this will give me 6 volt. So the output voltage here will be actually 6 volt. Go and try to solve the circuit as it is without simplifying it, and then you will find that the V output is actually equal to 6 volt.